and Saturday you should be finishing with the andrology session. So today might be a little bit loaded, and then you do just a little on Saturday to bring it to an end. So as a recap, we're going to have another session on Saturday, 7 to 9 as usual. And then you break for revision. And then the exams for this part will be held by the weekend. Then we restart the terminology itself the following week. That's the announcement. I have some malaria. I'm not too well, but I'll manage and make it. All right. So determine your titers. And the approach to titer determination is for all serological investigations. So if you have to be doing VIDA, if you have to be doing any serological investigation which requires titer determination, it's the same process. So the emphasis is on syphilis. I'm saying that it is the same for every titer determination. So make sure you understand it once and for all. Right. So we're saying that if the initial non-treponemal test result is positive, then there may be the need your antibody titers. All right. We wouldn't do so for the treponema because for treponema, once they become positive, there's not going to be any change. And so there's no need to do the titer determination for that. But for the non-treponema, because they have the characteristics of either increasing or decreasing, it means that the titer determination will help you. So that once there is an increase in the titer, it means that the infection is still there. All right. If there's a decrease in the titer, then the infection is being effectively managed. All right. So that is that. Now, the determination of the amount or concentration of the antibodies present in a patient's blood can help in both diagnosing syphilis and also monitoring treatment. What it means here is that if you are able to determine a titer and you are getting a value, it means that the antibodies are there and therefore the infection is there. So in one breath, you're using the titer to make a diagnosis. In another breath, you're also going to use the same titer to monitor the treatment. Like I said, if treatment has been effective, then the titer, which is the amount or level of the antibodies in the system, will wane down or will decline. All right. So the titer determination has two main benefits for diagnosis and also for treatment monitoring. Serial dilutions. But you may be old enough to have witnessed a certain scenario that occurred in Ghana sometime back during the term of President Jacob Kufuor. I'm sure you were old enough to have witnessed. There was something they were calling serial killing of women. You will hear that they have killed a certain woman here, and then next time, if the next time you hear it in Tema, or you call it serial killing. Do any of you remember all that incident where it was during the reigns of President Kufuor?
Yes, Dr. Bekele time.
Yes. So, but if somebody dies in Kumasi, somebody dies in Accra, you can't say it is serial death. The only way we can say that it's serial killing is when there seem to be The network has started again. I'm back. Can you hear me, please?
Yes, please. We can hear
Yes,
you.
we can hear you.
So if you are making a dilution is if you have a solution or a sample and you are adding water or you are adding some another solvent to shade, that you are making multiple dilutions, but one is depending on the other. That's why I took you to the element of serial killing when the operations of the killing that happened in Kumasi have a semblance of what happened and it seems to have a semblance of what happened. So if it's a serial dilution, it means that the dilution that you make, the next dilution is dependent on this one. And then the third dilution is also dependent on the second one. So that is the element of serial dilution, to the extent that one dilution depends on the other. Okay, that's the element of serial dilutions. So you can't make one dilution here, make another dilution somewhere, and another dilution somewhere, and say and call it serial dilutions. That is not. You are making independent dilutions, and that's not serial dilution. Once you make a dilution and the next dilution is dependent on the first, the third one is dependent on the second. The second one is also dependent on the third. That's where we are calling the serial dilution. So I want you to understand that principle very, very well. Right. So if you do it that way, then it means that from where you started, the stock solution, and for that matter, if let's say serum, that's your sample. And if you have a neat sample, neat urine, neat, what it means is that it is the concentrated, undiluted portion of the sample. That's the neat. So you have it as your starting point. You can also have a situation where you could prepare a certain stock solution. Okay, and that stock solution also becomes your starting point. So it doesn't mean that your starting point is always a neat solution. No, you could have prepared, let's say you have prepared a saline, and that saline now becomes your stock, or you prepare a ginseng solution, and the ginseng becomes your stock solution. Okay, so you see that that stock solution itself is already diluted, but you are taking it as your initial solution, and so it becomes your stock. So either your stock becomes your initial sample, or you are taking a raw sample like urine or any body fluid, including serum. That also becomes your starting point. And I'm saying that if you have serum or any body fluid which is undiluted, you use the word neat, N-E-A-T. All right. So you have a neat solution or a neat sample, and then you add in something, let's say water or a certain buffer or saline. Then you are diluting it. Okay, right. Once you dilute it, and then the next point is that you're also using what you have diluted to prepare another dilution. Then it becomes, because you are diluting alongside, then of course the concentrations are degrading or reducing along the path. I hope that point is clear. As you are diluting, as you are moving along, the concentration or the level of antibodies, as the case may be, as you move along the dilution train, you are reducing the quantities. And therefore, the dilutions, as you move along, the concentrations become reduced. I hope that point is also clear. All right. Okay. So dilution is the process of adding a solvent. And the solvent you're adding to the sample is called diluent. Some people call it diluent, whichever. Those of us who went to LA schools, you call it diluent. Those of you from the high schools, you may call it diluent, whichever. So whatever you are adding to the sample is a diluent. Now, it could be sterile water, it could be a buffer, it could be saline. And the saline here, we are making it 0.9% saline. What's the difference between 0.9% saline and just saying saline? You can tell me. If you say saline and if you say 0.9% saline, what is the difference? Please help me. Let's move fast because today we have a lot to do. Okay. Somebody has written that it's difficult to hear me. Please, is it better now?
Grandpa, yes, it's better now.
Okay, thank you. Already,
You,
I have flu, so the sound is quality of sound has already changed. So sorry.
okay.
I hope you can manage it. So what's the if you say saline and if you say 0.9% saline, what is the difference?
In the difference between normal saline and then the one with the 0.9.
No, if you are just saying, okay, prepare saline, and then somebody say prepare normal saline, and for that, you know that the 0.9% is your normal saline. If you say prepare saline, somebody says prepare normal saline, what's the difference?
The difference will be in the concentration. Maybe just saline will be maybe the stock. And then 0.9 is specific as to the concentration of it.
That's good. That's good. You see, but if you say saline, any salt solution is saline. Okay, any salt solution, even if you have a cup of water, you put in a grain of salt, it's still saline because that will have been a salt solution. Okay, irrespective of the concentration, it's saline. Any solution of water and then salt is saline. So once you say 0.9% saline, now you are being specific. Just as you said, you are being specific. And the 0.9% is what we call normal saline. All right. In under, well, there's a lot of technicalities on that. Let's take it that way. Because there's difference between normal saline and also physiological saline. But for now, we've come to agree that normal saline is the same thing as physiological saline. Okay. And then another name, what's another name for physiological saline? Other normal saline, physiological saline, what's the other name? This is way different from what, quite different from what we are talking about. But since we are still learning, we make sure that anything that comes our way, we must grab it.
Yeah.
So what's the difference? What other name can you give? Normal saline, physiological saline, and what? And isotonic saline.
No idea.
Isotonic saline. So if you say isotonic saline, physiological saline, normal saline, they're all the same. The only where there could be technically challenging is when you say normal saline. Because if you say normal solution, okay, a normal solution, what's the difference between a normal solution and a molar solution? This is also very, very basic fundamental biochemistry or chemistry. Okay. If you say molar solution, you're talking about that concentration that contains 1 mole of the substance. That's all. Okay. And then if you say a normal solution, that one too, it means that solution has a concentration of 1 normal. You remember that before we move to the molarity, okay, before it's like the imperial system and then the old system. Before we move to imperial system where you are using meters, okay, previously we were using, if you are measuring length, you are talking about feet, is that not it? Feet and inches. And then you move to meters, okay, meters and centimeters. All right, so when it comes to concentrations, you were using normality, normality, and then normality was changed to what we call molarity. So the difference is that this is the normality is an old system, and then molarity is the new system. So you can talk about 1 molar or millimoles, so forth and so on. Now, if you talk about normal solution, normals, I'm just bringing your mind to something. This thing, you may say that, okay, that it doesn't matter, but I want you to talk about critical science in this concept. All right. So if you say normal cell in the proper sense of the word, you are talking about a cell line which is of one normal. Okay. We are talking about cell line which is of one normal. It's the same thing I was talking about a cell line which is one molar cell line. So in previous terms, you could have said one normal cell line. Okay, so one normal cell line will have been a cell line that contains 1 gram equivalent weight, because that's how to define normality. Okay, now when you are talking about molar, you are talking about a solution that contains 1 mole of the substance. So for example, sodium chloride. What's the molecular weight for sodium chloride? Yeah, doing another basic sciences here. Don't worry. You understand why I'm doing that. What is the molecular weight for sodium chloride? Ladies and gentlemen, please, these are things you shouldn't forget to. Yes, molecular weight for sodium chloride.
It's 23 grams per mole.
But sodium alone is 23.
Sodium chloride, sorry.
Grandpa 58.
58, fantastic.
58.
If you want to prepare 1 mole, a molar solution of saline, what will it be? It means that weigh 58 grams of sodium chloride and dissolve in what?
1 liter.
1 liter. That will have been 1 molar solution, or 1 mole saline, 1 molar solution of the saline. It means that it will have been 58 grams of the sodium chloride in what? In 1 liter. How will you express that one in percentage? 58 grams of sodium chloride dissolved in 1 liter. That will give you 1 molar solution. Okay, 1 molar solution of saline. What is the equivalence in percentage? This is how you are able to
Hello. Hello. I think the network is.
There are a lot of things you'll be doing, and it's like, yes, I'm saying, so you all agree that 1 mole of the substance, and 1 mole is the molecular weight of 58. All right. So if you want to prepare 1 molar sodium grams of the sodium chloride, okay. So hello, can you hear me?
Yes, please. We can hear you now. It's
Thank you. My network. So all these discussions we are doing the program, but you see, we want to have you'll be able to learn so many things apart from the core subject on the discussion. So know that you can prepare 1 molar saline. Is that not it? Anybody can saline will have been 1 mole of sodium chloride in 1 liter of water. The question is, what is the molecular weight for sodium chloride? Molecular weight for sodium chloride is 58. So it means that you prepare 1 mole, you weigh 58 grams of the sodium chloride and dissolve it in 1 liter. That's fantastic. And that's 1 molar saline. 1 molar saline. This 1 molar saline, if you want to express it in percentage, what will it be?
Grandpa, it will be the 58 divided by 1,000 mils, which will give us 5.44.
Mm-hmm. But if you divide 58 by 1,000, we get 5.
hello, Grandpa.
Yeah,
Hello?
it will be 58 divided by 1,000 times 100.
Which can
44 is in 100. Okay. Yes, that's one way to do it is that. Okay, somebody has got it here.
I
But
didn't
if
see
you
it.
Rhoda has gotten it. But why, Rhoda, how did you get 5.48? Once, even though the gram, why do you get 5.48? It should rather be 5.8. You see, the 58 has been dissolved in 1 liter, which is the 58 grams has been dissolved in 1 liter, which is 1,000 mils. Is that right? 100. So all you have to do is to reduce the 1,000 to 100. How will you reduce 1,000 to 100? If you want to reduce 1,000 to 100, what will you do? If you have 1,000, you want to make it, you want it to become 100, what will you do? Ladies and gentlemen, these are 10. Very fundamental. Yes.
You divide by 10.
You divide by 10. So once you divide the 1,000 by 10 to give you 100, you must also divide your 58 by 10, and that will give 5.8. So now the 5.8 is now in 100. So 5.8 in 100 is 5.8%, and that is it. These things, like I've said, these days people wait and people prepare reagents for them and stuff like that. So you forget all, but you need this one to be able to train students. If you have level 100 or level 200 students and you are training them, these are the fundamentals that you must teach them. Okay, so that is that. So you see that will have been 55.8%. Okay, 5.8% will have been your the same thing as your molar solution, because after all, molar solution is 58 in the 1,000. So 5.8 in the 100 is still molar solution, and the percentage here is 5.8. 5.8 normal. 5.8 saline. Okay, 5.8 saline is in previous term would have been the normal solution. Would have been, because normality is the same thing as molarity. It's like I hope you are following me. Normality is the same thing as molarity. So if you are talking about a molar solution now, and for molar solution, the concentration now becomes 5.8. It means that if you are talking about normal solution, the concentration should be 5.8. And 5.8 saline, is it isotonic? 5.8 saline, is it isotonic? 5.8% saline is very, very hypertonic. So that's what I'm saying. Even though we use the term normal saline to represent 0.9%, but technically, the science behind it is a normal saline. The concentration will have been 5.8. But we try to ignore. Normal saline was coming from the fact that when laboratory started, that's why the doctors want to always think that, oh, we are under that we're operating their labs, and then they call people to probably support them, to be helping them, and that's the laboratory assistant. So do this for me, do that for me. And saline was one of the commonest reagents to repair in the lab. And they will just tell the saline. So, oh, if you want to prepare 1 liter of this, 1 grams in 1 liter. So weigh this. And then the next time, so weigh it the normal way that you do it. Weigh it the normal way. So now it became normal saline. So the normal is not with respect to the concentration. The normal is in respect to the fact that somebody has been trained how to prepare saline the normal way. So they use the word normal saline. Even though now we still adopting the word normal saline, but if you want to say normal saline, you must understand that its concentration is not the molar one, okay, but it's still 0.9. And even as scientists, also know this, as scientists, the actual concentration for normal saline, let me put it this way, normal saline is actually 0.85, 0.85%. It is only approximated to 0.9% because you also realize that now we have analytical balance that can give you 0.0003 or 0.001. Now the analytical balances that can help you to do that. In time past, they were using what we call a chemical balance. And that chemical balance can give you even just up to 1 decimal point. 1 decimal point. So to weigh 0.85% or to weigh 0.85 grams, you can't do that. So it was approximated to 0.9. And now we have adopted the 0.9. But if you are doing any scientific work and you quote 0.9, if you have an examiner or a supervisor who is very critical, he will mark you wrong, especially if you're doing, let's say, PhD or master's program where they want you to be very exact. If you quote saline to be 0.9%, if you get any examiner who is very critical, he will mark you wrong. So even though routinely in the lab, we still accept 0.9%. We still accept the 0.9%. But I just want you to know that the actual concentration is 0.85%. But it can be approximated to 0.9. So take note of some of these things and to help you in future. Right. So to prepare 0.9%, it also means that just weigh 0.9, sorry, it is 0.9 grams in 100 mils, because percentage means over 100. So 0.9% means 0.9 grams in 100. So if you want to prepare, let's say 2 liters, if you want to prepare 2 liters of saline, what will you do? You want to prepare 2 liters of normal saline, and normal saline here, you're talking about 0.9%. What will you do? 2 liters of normal saline. What will it be? This is basic science. So the line is breaking. The line is breaking. And this is a cheap question for everybody. I'm saying that you want to prepare normal saline, which has a concentration of 0.9%. I've explained that now all of us are using normal saline. Okay, but so forget about the explanation I gave you was to give you the history behind normal saline and normality and molarity and so forth and so on. Now you all accept that normal saline has a concentration of 0.9%. Good. You want to prepare 2 liters of normal saline in your lab. What will you do? How will you prepare it?
Please, Grandpa. Hello, Grandpa. I think. Hello.
If you lose 10 marks. Yes, I'm hearing you.
Please, I think with this one, you can measure, when you measure using the analytical balance, you can measure 0.9 grams. Hello?
Yes, I'm saying you are preparing 2 liters. 2 liters of saline, of normal saline.
No.
Yes, sir.
Okay, Grandpa.
Yes, sir.
Since you are preparing 2 liters of the normal saline, we are going to need 18 grams of sodium chloride.
That's big. That's great.
18
so
grams.
How do you get your 18 grams? The 18 grams is coming from the 0.9% means 0.9 in 100.
Yes.
So you first have to work out what will be 1 liter. 1 liter will be 1,000 mils. So for the 100, you have to multiply the 100 by 10 to give you the 1,000. Once you have multiplied the 100 by 10 to give you 1,000, you must also multiply the 0.9 also by 10 to give you 9. All right, so for 1 liter, you need 9 grams. So now they say prepare 2 liters. So prepare 2 liters. On the right side, you already have your 1,000 mils. So you multiply that also by 2 to get your 2,000, which is the 2 liters. And the left side, which is the salt side, you're also going to multiply the 9 by 2. So you get 18. And then doing that until you get 2 liters. That are small things you shouldn't forget come around. And these are the very, very things behind the things that yes, sir.
Please, I also had 18, but this is how I
But you
did
can
it.
also do cross multiplication, you get it.
Yeah.
Go ahead. Go ahead.
Grandpa.
Okay. So how do you get it? Okay, let's move on. Yes, sir. Please, I'm listening.
0.9 is equivalent to So if I want to prepare 2 liters, that 2 liters will give me 2,000 mils. So 2,000 mils by 0.9 divided by 100 mils will give me 18 grams.
Okay. All right. Okay. That's okay. All right. Good. So we move on. So we are saying that to repair serial dilutions, you still need a diluent. And that diluent or diluent is a solvent, which you are going to add to your sample. And that diluent could be ordinary water, it could be a certain buffer, it could also be saline. And in fact, in most of serological work, we rather will use saline. And I wanted us to have an idea about the saline, the fact that 0.9% saline is the same thing as physiological saline, same thing as normal saline, is also called isotonic saline. And whether physiological, normal, or isotonic saline, they are all 0.9%. But if you understand why they are called physiological, the same solution is called physiological at 1% normal. Okay, I want you to note that. I don't want to go beyond all the, otherwise we will be going round. I'm saying that 0.9% saline can be called physiological saline. It can also be called isotonic saline. It can also be called normal saline. The three names can be used interchangeably, but you should be able to appreciate you. Why do you call physiological saline to find out? I remember sometimes you ask somebody, what's the difference between physiological saline and normal saline? He will tell you that the physiological saline is 0.85% and normal saline is 0.9. that is not it. Any one of them is 0.9%. And the 0.9 I've told you is actually an approximation of the 0.85. Okay, right. So let's move on. Serial dilution involves the process of taking sample and diluting it through a series of repeated dilution with a solution or diluent to create a series of decreasing concentration. This is what I've tried to explain already. You are going to create a series of concentrations that will be decreasing along the line. So from where you started off, as you move along, the concentrations will decrease. And you understand from the next slide why it should decrease. Okay, here, say that the technique, that's the serial dilution, allows for the preparation of multiple dilutions, which provide a range of decreasing concentrations for testing analysis. Now, for this serial dilution, it will involve a certain constant, which is called dilution factor. All right. Now, we will take you through how to determine your dilution factor. So, the dilution factor of each tube, okay, in a set of serial dilutions is calculated as follows. So you see that, let's say you have right. If you take 1 ml in your diluent, and now have your serum 1 ml, you are adding saline 1 ml to it. What is the total volume you have gotten? So this is class 1. You have 1 ml of your serum. That's, you are diluting it with another 1 ml of saline. What is your total volume now?
2 ml.
2 ml. Out of the 2 ml, how much of a sample is in the tube? How much of the sample is in the 2 ml?
Grandpa, please come again. The line is not clear.
Just you answered correctly. I'm just a follow up. Say you have 1 ml of the sample, and then you have 1 ml of the diluent. You mix it, you get 2 ml. That's the total volume. Out of the 2 ml, how much of the sample is in it?
1 ml.
Okay, yeah. All right. I'm saying you are making a dilution, and in this dilution, you added Okay, you have a solution of this in the 2. The question, how much? 1 mil is your dilution factor. 1. So mathematically, the way to do it is that over the volume of the sample and the volume of the diluent. Okay, because you have your diluent of 1 mil. So you are now having a solution which has a volume of 2 mils. Out of the 2 mils, you have one volume in the 2. So there's 1 in the 2. That's all. That's all. This is your sample to solution ratio. And the solution here, you're talking about the volume of the sample and then the diluent. That makes up the solution. So if you call this a ratio of the sample to the solution, you should understand this. Please, these are so basic that you don't have to forget some of these things. All right, you don't have to forget some of these things. And these are the things that you need. Once your fundamentals are good, I learned these things, and so many years, I don't even read to get them again, because you understand it from the basics and become part of you. Okay, so understand the things from the basic science point of view, and you always be good to go. You always be good to go. Make sure that you're understanding what you are doing from the basic science concept. So your dilution factor here is just a ratio of the sample that you are taking over the solution. And what's the solution? The solution is the sample plus the diluent that your sample that you are working with, plus the diluent that you have added. And so that is it. So dilution factor is simply the volume of the sample over the volume of the sample and the volume of the diluent. That's all. Good. I hope you are following. And I'm just going slowly like this so that wouldn't understand. If you don't understand, call my attention, because I want to make sure that at the end of the day, these things you're able to do them on your own. Right. So where you have fluent, when you say 1 part, that 1 part could be 1 mil. It can be 1 gallon. It can be 1 liter. So that's 1 part. All right. Now, even if you say the 1 part means 2 mils, and the other, if you want to make 2 parts, and you say the first part is 2 mils, what should be the second part? I want to make 1 part and 1 part together. The first part, I'm taking 2 mils. What should be the second part?
2 mil.
The second part should also be 2. That's great. So once you do this one, you also motivate me. You make me happy. Okay, you should understand this. We are making 1 part to 1 part. This 1 part, I'm making it 2 mils. So the other part too should also be 2 mils, so that they can always be said to be 1 part and 1 part. Okay, so if I make my 1 part, let's say 50 microliters, the other part should also be 50. That whatever you did for the 1 part should also be done for the other part. So if I say that my 1 part here is 1.5 mils, then the other part should also be 1.5 mils, so that they all be 1 part and 1 part. Okay, where you have 1 part and 1 part coming together to give you 2, and you are repeating that becomes 2-fold dilutions. Okay, or what you call doubling dilution. You are only doubling it, like the first example that we made. 1 mil and 1 mil. You're only doubling your parts. So it becomes a doubling dilution. Okay, if that is what you are going to carry through your serial dilution, because you said serial dilutions, when you are preparing multiple dilutions, and the first dilution, that second has a reflection on third dilution, that's a serial dilution. If at each point you are doubling it, it becomes doubling serial dilution. Ladies and gentlemen, bring me back and let me make sure that you understand it. Doubling dilution. If I make 1 ml and another 1 ml and I put them together, it's a twofold dilution. If from this twofold dilution, I'm going to make another dilution from the first dilution that I made, also make it a doubling dilution again, then it means that I'm now going to prepare doubling a serial dilution. And the serial dilution is all double. So it becomes serial doubling dilution or a twofold dilution. If you are repeating it along the series, it becomes doubling dilution. Okay. All right. So in this case, your dilution factor is calculated as, okay, you're divided by the volume of the sample and the volume of the diluent. Okay. Right. So for the twofold, the volume of the sample here, you said it's 1 ml or 1. The volume of the sample, which is 1, which is also 1, because we are there's another bad day for network. So I've made it in such a way that once you follow it, I'm sure you. Okay. So you now know how to calculate dilution factor. Dilution factor, you must know the volume of the sample that you are taking. Okay. And you should also know the volume of the diluent that you are taking. So your numerator will be the volume of the sample alone. The denominator will be addition of the sample and then the diluent. Okay, and that's all. A series of twofold dilutions is described as serial doubling dilutions. I've said this already. Okay. So we are going to look at what we call a tenfold dilution. A tenfold dilution. A tenfold dilution means 1 in 10. A tenfold dilution. One said a twofold dilution means you're going to have 1 in a 2. Twofold. The sample part will be 1, and then the solution part will be 2. So to have, so let's go back. For a twofold dilution, it means that your total volume should be 2, okay? And then the sample you need to be 1, so that will be 1 in the 2. Now, in this case, it means that the sample part is 1, and the solution itself is also 2. So what is the diluent? 1 in the 2. The solution is a combination of the sample and the diluent. So if you say 1 in the 2 and the sample part is 1, the total volume is 2, 1 in the 2. What is the volume of the diluent?
Also 1.
It's also very good. Joe, that's good. So we are talking about 1 in the 10. 1 in the 10 means that solution is 10. Remember, the 10 is a combination of the sample and the diluent. So if the solution is 10 and the sample is 1. What is the diluent?
9.
9. Great. Joe, that's great. So you are making my day. Once you understand it, that is all. I want to make sure that you understand. So a tenfold dilution is saying that it is 1 sample in a 10. And the 10 is your solution. And the solution is a mixture of the sample and the diluent. So if the sample is 1, automatically your diluent should be 9. This 9 will add up to your 1 to give you a 10. And so now your ratio now becomes 1 ml over 1 ml plus 9. That will give you 1 over 10. This is another expression of 1 over 10. Mathematically can also be expressed as 10 raised to the power minus 1. You know this already. So that's all. So if you want to do a y in 5 dilution, a y in 5 dilution will mean 1 in a solution of 5. Y in 5, the solution of 5. So if you take 1 ml, what will be the equivalent of the diluent?
4 mils.
1 ml. Wait, that's all. So the dilution factor should not confuse anybody. Should not confuse anybody at all. The only thing here is that if you say 1 in 10,
Also, like this man, what's your problem?
and watch here, if you say 1 in 10, it means that your sample is going to be 1 and your diluent is going to be 9. Okay? But it does not necessarily you should take 1 ml and 9 mils. Gladys, will you off your mic?
Hey, God, so
You are becoming a notorious listen. Okay. Right. So listen and listen good. 1 in 10 means 1 part of the sample and then 10 of the solution. In that case, your diluent is going to be 9. So that it's going to 1 and 9, and then the 1 plus the 9 will give you the 10. Okay. It does not, and take note here, it does not necessarily mean that the 1 and the 9 should always be 1 ml and 9 mils. No, it shouldn't be like that. It is 1 part to 9 parts. And the 1 part can be anything. It can be anything. And the 9 parts can also be in. So the 9 parts will not be dependent on what you take for your 1 part. So please, I'm saying that 1 in 10 means 1 mil. For example, if I want to take the 1 mil, it's 1 mil plus the 9 mils to give you the 10. Okay, so you get your 1 in 10 straight away. I'm saying, and take note here, that the 1 and the 9 does not necessarily means 1 mil and then 9 mils. Okay, I'm going to give you an assignment, and I need the answer now. You want to prepare 1 in 20 dilution. 1 in 20 dilution. Please, all of you, take your papers. You are going to prepare 1 in 20 dilution. Okay. Now, for the 1 in 20 dilution, and this one was very practical in the days when people were doing the manual WBC count. The manual WBC count, the WBC. Okay. Hello, are you following me? The WBC diluting fluid, remember we mentioned it. The WBC diluting fluid is also called what?
Test fluid.
Very good, great. If you do this, you make me happy. Test fluid, and test fluid is just about 3% acetic acid tinged with either ginseng or chrysoberyl. Good, and that's fantastic. Great. Now, in that method, if you wanted to do WBC count, they took 20 microliters of 20 microliters of the blood. You took 20 microliters of blood sample. And then if you are to prepare 1 in 20 dilution, what will be the volume of your test fluid that you have to take? You are going to prepare 1 in 20 dilution. The blood sample is 20 microliters in 20. Yes. I need answer, please. Come again.
The sample.
The first person. The sample. I'm saying the sample is your blood. Okay. And you are going to do a 1:20 dilution. The sample is 20 ml. The text fluid is going to be your diluent or your diluent. Okay. You will need 1:20 dilution. Sorry, 1:20 dilution to prepare to proceed. What volume of the text fluid must you take?
Ml plus
1 to 1 to 19.
Not getting it. I'm saying that now. I started by saying that your 1 and 19, of course, which will give you your 1:20. Okay. If you take 1 ml and then 19 mils of your diluent, at the end of the day, you are going to get a solution of 20. And therefore, your 1 in the 20 will be very simple. But I'm telling you that the 1 and the 19 is not automatically 1 ml and 19 mils. For example, if you are going to do a WBC count, you don't need 1 ml of the patient sample.
Please, you take 3.
3.
380.
Yeah. Come again. 380 microliters. Great. Oh, Bernard. Is that Bernard? Who answered this? The line is bad. Who answered it? Is that Bernard? Hello? Hello? Oh, who did that great job for me? I didn't get the name. Please, can you hear me?
We can hear you now, Grandpa.
Okay. So somebody gave a very correct answer, and I want to know who the person is. Do you agree that it should be 380 microliters?
Yeah.
The feedback
Yes,
is
Grandpa,
bad.
we agree.
You are doing it, okay. But somebody has already done it, and I want you to, and that answer is correct. And I want you to make sure that you understand it. Who gave me the 380 microliters?
Grandpa, it's me.
Bernard, good.
Yes,
Can you take them through? Can you take them through for me?
Okay. Because we are preparing 1:20 dilution. And then the blood sample we are taking is 20 microliters. You just have to multiply the 20 microliters by 19.
That's all. That's all. Because I said by saying that the 1 in 20 means 1 part of the sample and the 19 parts of your diluent.
Nice.
And the 2 will give you your 20. Okay, so 1 in the 20. Now the 1 is not necessarily, and I repeated that one, it's not necessarily 1 ml. It can be anything. The 20 microliters multiplied by 19. And that is going to give you 380 microliters. When you work out, you realize that the 20 microliters plus the 380 microliters will give you 400 microliters. Out of the 400 microliters, how much of the sample is in the 400? Yes, you can tell us. Out of the 400 microliters, how much of the sample is in it?
20.
Yes, it's 20. So it's the 20 in the 400. If you divide 20 over 400, you get 1 over 20. So these things should, in fact, you can work out a lot of these things. Okay, you can work out a lot of these things, and it is important that you should know some of these things. Even though these days nobody does manual or VC count, but you see, sometimes some people, to the extent that now some people don't even know how to use neighbor counting chamber. But you can't do a neighbor counting chamber without, you can't do without the you can't do semen analysis without the neighbor counting chamber. Okay, you can't do it. So you must know, and in the neighbor counting chamber, the principle of dilution will be applied. If you're doing WBC count, these days some people they will use a machine, the analyzer, and the analyzer may not be able to get a certain value. You know that for every machine, there is an upper limit and a lower limit of detection. Sometimes your WBC count may be so high, and then the machine cannot read it, and then you give you X, 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 X. And then you see lab scientists releasing that report. When the machine has not been able to detect it, that's where the element of reflex also comes in. If the machine is not able to do it, then the reflex will be what? What will be the reflex? If you have a machine and that has gotten to its limit and is not able to give you a correct result, what will be the reflex? Who can try? They're using, have you come across the scenario I'm talking about before?
Yes, please, Grandpa.
Yes. And do you allow the report to go?
No.
No, we have to do the manual WBC count. Yeah, hello.
Yes. So the reflex is that if the machine is not able to if this is the go back, because we didn't go back. Machine, so the reflex will be a manual test. And now if you the person to if accurate so high, you see the dilution, you can't count. The cells will be too much that you count. You now do it, and that becomes an element of serial dilution. Because serial dilution, you are going to do dilution, a previous dilution that you have made. Okay, so please, these are the things that makes you a scientist. If the host is around, I went off again and I'm back. Can you Please, coordinator, can all right. Whilst waiting for permission to share, if you have any question or difficulty with what you are discussing, let's know. Because I want you to build a capacity to do these small things on your own. Is there any challenge?
Hey, seriously. Machine is doing things, and I will do things in life.
All right. So still waiting, but the thing to do is that if you have to do a serial dilution and the first tube, in your first tube, for the sake of simplicity, you take 1 ml of your sample and you take 1 ml of your diluent. That gives you 1:2 dilution, okay? Now, in the second tube, of your first solution, which you have prepared, you take 1 ml of the first solution that you prepared, and then now take 1 ml of your diluent. You are dealing with the second tube now. The first tube, 1 ml of your sample, the blood sample or serum, and 1 ml of your diluent. In the second tube, you take 1 ml from your first tube and then add 1 ml of your diluent. You realize that you are preparing another 1:2 in your second tube. Is that not it? Because dilution factor is just your sample, the volume of your sample, plus the volume of your sample and your diluent. So you realize that in the second tube, you have also prepared
Hello, Grandpa.
Okay.
Hello.
Hello.
Please, your screen is not showing.
Yes.
Your screen is not showing.
Yes. I went off and yes, I know. I said that I went off and unfortunately the host is still not allowing me to be able to share my screen. I will do that. Is that okay?
That's fine.
Hello.
Thank you. That's fine.
I'm
Thank
saying that
you.
I went off and the host is still not available to give me access. So I'm just doing a talking. I'm saying that you have 2 tubes. The first tube, they are preparing 1:2 dilution. And the 1:2 dilution for the of simplicity, you are just taking 1 ml, 1 ml. Can be any as we did, for example, of the WBC count. So if you have 1 ml of your serum and 1 ml of saline in the first tube, you mix it. In the second tube, you take 1 ml from the first tube, and then you also add 1 ml of saline. You realize that in the second tube, you have also prepared 1:2. Is that all right? Do you agree with me? In the second tube, you have also prepared another 1:2. Yes. But the 1:2 that you have prepared is coming from a previous 1:2. So your current dilution factor will be 1:2 of a 1:2. Okay, it is 1:2 of another 1 in 2. So all you do is to multiply. So because mathematically off means times, okay? Off means, so you have a 1 in 2 of 1. That will give you 1 4. Okay. So you move on to the third tube. In the third tube, you're also taking 1 mil from the second tube into a third tube, and then add 1 mil of your diluent to the third. 1 in 2 that you have prepared is also coming from the second tube, which has a dilution factor of 1 in 4. So it is now 1 in 2 of a 1 in 4. And so it becomes 1 in 2 times 1 in 4. And that will give you 1 in 8. This is the way you do the calculation for serial dilutions. All right. Now, let me give you a certain scenario.
That family is a very good family to my family. Mm-hmm.
Right. Please pay attention. I'm giving you a certain scenario. I want you to work it out. You have 0.1 mil of a serum sample, 0.1 for a serum sample. And then you add 1.9 mils of saline to it. Calculate the dilution factor. You have 0.1 mil of your serum, and then you have added 1.9 mil of saline. What is the dilution factor?
$20.
Come again. Come again.
It's 1 in 20.
1 in 20. 1 in 20. As simple as that. 1 in 20. Okay. Who has a challenge in that?
I have a challenge in that.
0.1. You have a challenge?
Yes.
Who has a challenge? You have a challenge there?
Yes, please.
Okay. So what it is that the sample is 0.1 mil. Your diluent is 1.9 mils. So what is the total solution?
That's 2 mil.
What's the total solution?
Total solution is 2 mils.
Very good. What's the volume of the sample?
0.1.
0.1. So it is going to be 0.1 over the 2. If you have 0.1 over 2, what will be the, if you want to make it 1 in something, what will you do? You have to multiply the top 0.1 by 10 to give you 1. Because now you have 0.1 over 2. We want 1. So for the 0.1 to become 1, you must multiply it by 10. Once you multiply the numerator by 10, you must also multiply the denominator by 10. So the up can now become 1, and then the bottom can become 20. Is that all right?
Yes, sir.
Hello?
Yes, sir.
Is that all right for you now?
Yes, sir.
Okay, so that's your 1 in 20. Good. Now from this tube, okay, from this tube, you take 0.5 mils of this of this tube. You take 0.5 mils, and then you take 0.5 mils of your saline, okay, and prepare another solution there. What will be the dilution factor in the second tube that you have prepared? This to everybody. So you now know that the first tube, your dilution factor is 1 in 20. From this, you take 0.5 mils into a second tube and take another 0.5 mils of your diluent and add it to the second tube. What is the dilution factor in the second tube?
One in 10.
Come again.
I also think 1 in 10.
Rework it.
1 in 2.
Try it again.
How about 1 in 4?
Try it again.
How about 5?
Hey, are you making trial and error?
1 in 40.
That's
1 in 40. Great. Who are you? Let me know and give
Yeah.
you some mark, bonus mark down. Who is that?
Please.
Who is that? Is that Chris? Who got the 1 in 40? Oh, you can. I'm just clapping for you. And who got the 1 in 40? Who got the 1 in 40?
Yeah.
I heard somebody say 1 in 40, or it wasn't
I
coming
think
from
the network, so the person is not actually hearing.
I
Some
think
lines
it's
are
network
breaking.
as well.
Okay. So you see that in actual fact, in the second tube, you have actually prepared 1 in 2 dilution because you took 0.5 mils of a certain solution, and then you are adding 0.5 mils of your diluent. So that tube alone is 1 in 2. But this 1 in 2 is coming from the first tube, which is already having a dilution of 1 in 2. Okay, so it is 1 in 2 of 1 in 20. So it is 1 over times 1 over 20. That will give 1 in 40. All right. So that is fantastic. And this is what we do. In fact, in the similar analysis that you'll be doing, you will always be preparing 1 in 20 dilution. Okay, you always be preparing 1 in 20 dilution. Now, if you do a 1 in 20 dilution and you see that the count is high, you don't have to go back to the what do you call it? You don't have to go back to a sample and restart. So the preparation, you can do a serial reaction from there. Okay, so if my tube is 1 in 20 dilution, and now I saw that the sperms, or for that matter, the cells are too many and I can't count, you have to do a further dilution. So I come and take my tube, and then I take, let's say, 2 drops. Okay, listen here. I take 2 drops of the 1 in 20 dilution that I've made already. And then I add 6 drops of my diluent. Okay. Listen and listen good. I'm saying that your starting dilution is usually 1 in 20. Here you're talking about semen. Okay. And then I saw that, oh, the sperms are too many. And then from there, I take another tube. I take 2 drops from the initial solution. And now I'm adding 6 drops. Remember, I've said that the 1 part to 1 part of something is not necessarily 1 ml. It can be anything. And here I'm using drops. So I take 2 drops of this solution, and I'm adding 6 drops of my diluting fluid, which is my diluent. What is the dilution factor in the second tube that I have prepared?
1 in 80.
Great. Is that
Please come again. I did, Joseph.
I'm not able to get a person.
Joseph.
Who answered? You answered, Joseph.
Yes, please.
Who gave me the 180?
Yes, please.
Yes.
Joseph.
Can you explain to your colleagues? Can you explain to them? Yes.
Okay.
Yes. I said, can you
So
explain to your colleagues?
initial, yes, please. The network is bad at my end, so maybe the voice would be breaking alongside.
But I can hear you. I can hear you. I can hear you, please.
Okay. So we already have the initial dilution factor at 1 in 20, of which we took 2 drops, as you said, and then per the formula that we had already, the new sample is 2 over the volume of the new sample plus the volume of diluent, which will give us 8. So 2 over 8, which is further broken down to 1 on 4. Then I multiply the 1 on 4 by the initial dilution factor of 1 to 20. And that gave 1 on 80.
Right. 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 Good. Good. So at least I've not so here the 2 drops plus the 6 drops giving me 8 drops. Out of the 8 drops, I have 2 of the specimen in it. So that will be 2 over 8. And that will work out to 1 over 4. So it means that in that tube, I have 1 in 4 dilution. But technically, the 1 in 4 is coming from a previous 1 in 20. Okay, so it is 1 over 4 of the 1 in 20, which is 1 over 4 times 1 over 20. That will give you 1 in, I mean, once you get to Siemens analysis itself, all these things will come to play. And you don't have to worry and it's the same thing that will play out if you did a manual or BBC count. And let's say the machine, sorry, if you did an automated to do a further dilution, you can do 1 in 5 dilution. Okay, if you do 1 in 5 dilution, that 1 in 5 dilution, you can, it's one part of the sample, the one that the preparation that we have already made, which is 1 in 20. You take 1 part, you can take 4 parts of the dilution fluid. Okay, if you make it 50 microliters or 1 drop, then it means that the diluting fluid too can also be 4 drops. So if you have 1 drop to 4 drops, you are making a dilution factor of 1 in 5. If you multiply 1 in 5 by the 1 in 20 that you have already, you get 1 in 100. And you see, you substitute the 100 in the calculation for WBC and it gives and makes it very simple. If you don't do that, you make any dilution, any calculation, it can be very difficult. So the easier way is to give a dilution factor of 1 in 100. Okay, if you do a dilution factor of 1 in 100, you can easily get it. And the way to do it is you should prepare 1 in 5 dilution from your initial preparation, which is already 1 in 20. And that will give you a preparation dilution factor of 1 in 100, which can be substituted in the equation. All right. So if you have a challenge, please let me know. And unfortunately, the coordinator still has not allowed me. I'm sure he may have left the scene and he's not still allowing me to share my slides. All right. So, can you hear me, please? Hello?
Hello, fellow.
Yes,
You can
yes.
share your screen now.
Okay.
Sorry.
I hope you can see my screen now.
Yes.
All right. So this is a perfect example of a twofold or doubling. When you say twofold, you are doubling it. So that's a twofold or doubling dilution. Once it is going to be a series, then it becomes doubling serial dilution, as I said earlier. All right. You multiply the dilution factor at each step, resulting in a progressive drop in concentration. So here you have 50 microliters of a what you do here is to put 25 microliters in all the tubes. This is tube 1, tube 2, 3, 4, 5, 6, 7, 8. Okay, so you put 25 microliters of the diluent in all the tubes. Just put 25 microliters in all the tubes. Okay. Then you take this your test sample or your serum. You take 25 microliters from here, from the sample to the first tube. Okay. Now, if you put 25 microliters, because you already have 25, you've added another 25, so it gives you 50. Out of the 50, you have 25 in the 50. So it becomes 25 over 50. If you work it out, you get 1 over 2. So this is your 1 into, this is your dilution. Okay. Now, you mix here and take another 25 microliters from here and bring, remember that all the tubes here already have 25 microliters in them already. So you mix here and then you take another 25 microliters from here and come and add it here. If you add it here, effectively you have prepared another 1 in 2 dilution here. But this 1 in 2 is coming from a previous 1 in 2. So it is 1 in 2 of a 1 in 2. So you multiply 1 in 2 by 1 in 2. So that will give you 1 in 4. Okay. Now you mix here again and then take another 25 microliters from here and bring it here. If you bring it here, this already has 25 microliters in it already. So you are adding another 25 microliters in it. And here you are preparing under 1 in 2. Okay. The 1 in 2 you are preparing is coming from a previous tube, which is 1 in 4. So this place becomes 1 in 2 of the 1 in 4. You multiply. So this place becomes 1 in 8. So we move on like that. So this also, you mix here again. You take another 25 microliters from here, bring it here. This tube, like I've told you already, you have already put in 25 microliters all throughout. So this also has 1 in 2 already. Sorry, 50 microliters already. 25, sorry. And then you are bringing another 25. So you are preparing another 1 in 2, which is coming from this. So it is 1 in 8 of 1 in 2. So you see that this is the way to go. So you see that this 1 over 2, 1 over 4, 1 over 8, 1 over 16, this is what you call doubling. Because you are only doubling, when you double this, you get this. 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 Double this, you get. So this is what we call doubling, and then it's a dilution. So it's a doubling dilution. And because it's a series, like I told you, when what is happening has a connection with the previous one, it becomes a serial. So this becomes a serial dilution. Serial dilution, because there's a dilution you are doing here is coming from here. The dilution you are making is coming from here. That makes it serial. All right. And you are doubling them. So it becomes doubling serial dilution. As simple as that. So this is how to prepare. And then here you are discarding, because once you mix here, and then you have taken 25 here, what is left here? How much is left here?
25.
25. So you'll be doing that. So at each point, you'll be left with 25. So here, which gives you 128. If you don't take 25 out of it and discard, this place is going to be 50, while the rest is going to be high. So if you're going to do a test with them, this one will be more. So you discard. Okay. You discard here, so that all of them will now also contain 25 microliters. If you have to do a test on them, if let's say you are using this one to do a test, sorry, if you are going to use this one to do a test, then you see that you did the test on your sample. Okay, you did a test on a sample and it was positive, and you decided to be diluting. You started to be diluting. Then you use this one as a sample, as though it is a sample, and you do the test, and it's also positive. You do this one to the second tube. You use it as if it is a sample for the test, and it was also positive. You did here, and it's also positive. You did here, and it's negative. What will be your titer?
To be the 1/8.
1/8.
Hello, Grandpa. Hello.
Able to, yes, sir.
It should be
Hello,
the 1
I can
over,
hear you.
It should be the 1/8.
Great. And I'm saying that once you do this, you make me happy, because I know that you are following and you're understanding it. Okay, right. So this is the last tube that gives you a positive report. And so this becomes your last or the highest dilution. And so your titer is this point and not this one. Which means that from here, all the rest can okay. Assuming this one was positive, this one was positive, and this one a negative report. What will be your titer?
Grandpa, come again. Your line went
Okay,
again.
sorry. Okay. So I'm saying that in the same vein, you are doing the test and all the tubes here were positive, except this one, which was negative. What will be your titer?
164.
That's all. So determination of titer is very simple. The only thing is that you should be able to do your serial dilution. Once you do your serial dilution, you'll be what the trick to do. Hello, the trick to do, because if you don't take care, if somebody has a very high titer, one case, by the time you finish, all your reagents will be finished. All your reagents will be finished. So what you do is that, let's say you do this one. Of course, the sample must be positive before you decide to do a dilution. Is that not it?
Yes, please.
If the sample is negative, why
hello,
do
Grandpa.
a dilution? Unless, hello.
Please, I wanted to ask a question. Please, I'm only seeing the volume of the sample. So what will be the volume of the diluent that will be adding?
Volume 25.
Okay. So for each case, you have to follow the manufacturer's instructions. If the manufacturer says take 10 microliters or take 1 drop, so be it. Okay. So be it. What I'm saying that now, after your dilutions, you are taking each of them as though they were the sample. And here I'm using 25 microliters. That doesn't mean that you should always be taking 5 microliters. So it can be the 1 mil. It can be 50 microliters. It can be 0.1 mils. Okay. Just understand the principle. All right. So if your test sample is negative, why will you do? Under what condition will you do the serial dilution if this one is negative? Under what condition will you do a serial dilution if this one is negative? Why will you do a serial dilution? Under what condition?
So it's what you did. Good.
Hello. Hello.
Okay. So I said,
I'm saying that under normal circumstance, you do serial dilution only if your test sample is positive. Now, I'm saying that under what condition will you still be doing serial dilution if this one is negative?
We added so yeah,
someone's line is mic
just
is
think,
up, so we can't hear.
Please, I'm saying that you can only be doing dilution if your
No, Grandpa is off again. Hello, Grandpa. Hello, Grandpa.
Yes, sir.
So
allow
with
me,
a
please?
yes, with a question.
Okay.
With your question.
Yeah, so the question.
I think that
yes, please.
The serial dilution can still be done if it is negative because of the prozone effect.
Fantastic. Great. I'm proud of you. You see, once you give me this answers, and which is very refreshing, I feel so glad, because at the end of the day, I want you to take home something. I want you to have learned something, okay? Not just brushing through and then getting your certificate. So that's fantastic. You can still go ahead and do yours if there's a high suspicion of a prozone effect. Okay. So that's great. I love that. All right. So I'm waiting for all right. So permission has been granted for me to share again. So in your serial dilution, in this particular case, we are using the 25 microliters. It doesn't always have to be 25, not at all. It can be any volume, except that if you are doing doubling serial dilution, the volume which you want to start with can be 1 ml, it can be 500 ml, it can be 100 microliters, can be anything. Should be the same across. And then the volume that you put here must also be the same volume that is coming from your sample. Okay. And once you mix here, you do an initial 1:2 dilution. And from here, you are going to do under 1:2 dilution. Under 1:2 dilution. That's taking the under volume. In VIDA testing, you will have the tube test, and then of course we have the slide test. The slide test, that one you don't do serial dilutions, but you also do volumes. You take volumes that also commensurate with the serial dilution, okay? Because that's a different dimension. I just want to give you this narration that with the VIDA, you are going to do something different, because you want titers in the range of 140, 180, 160, you understand? So what you do is that you do an initial 1:20 dilution. And how to do 1:20 dilution, that one you have to determine yourself. 1:20 dilution means 1 part of the sample to 19 parts. Okay, that will give you your 1:20 dilution. Then the 1 part you can decide. This 1 part, should it be 1 ml? Should it be 100 microliters? Should it be what? So if you decide to make it 100 microliters, which is 0.1 ml, then the 19 parts can also be what? 1.9. So it means that your first tube is 1:20 dilution. Then from the first tube, you can decide now to be preparing doubling dilution, serial doubling dilution. So you now be preparing 1:2. And so what you do is, if let's say you decide to put here 50 microliters, so 50 of all the diluent, which is normally saline, you put 50 microliters of saline all three out here. And then you come and pick 50 microliters from your first tube. You have the first tube, you have already done your own calculation and prepared 1:20 dilution here. So you take 50 microliters from here and come and add it to your 50 microliters here. And so it means here you have prepared 1:2 dilution. But this 1:2 dilution is coming from 1:20. So this place becomes 1:40. And then you take another 50 microliters from here and come and add to your 50 microliters saline here. This gives you another 1:20 dilution. Sorry, 1:2 dilution coming from 1:40. So this place becomes 1:80. So you see that you are using a combination of a higher dilution here, which is 1:20, and then now doing your doubling dilution. even though you didn't start with a doubling dilution. Okay, you didn't start with doubling dilution. You started with a stock dilution of 1 in 20. And now from here, you are preparing your 1 in 2, 1 in 2, 1 in 2, 1 in 2, 1 in 2. And so the 1 in 2 now becomes 1 in 40, because 1 in 2 from 1 in 20, that becomes 1 in 40. This becomes 1 in 80, 1 in 160. So that once you do your test, and let's say, so it means that this place becomes 1 in 40, 1 in 80, 1 in 160, 1 in 320. If you do your test, and at this point, it is positive, but this point is negative, it means your titer is 1 in 320. What I was saying previously is that in order not to waste your reagent, because you are going to be, for one case, if the case has a high titer, you do this one, is positive. You go and do this one, is positive. You go and do this one, is positive. Remember, at each point, you are adding reagent. Before you get here, one case has finished all your reagent. So what you do here is that you look at the reactivity, okay? You look at the reactivity. Let's say it is positive here. All right, you did a test here, it is positive. You look at the clumps. If the clumps are too heavy, it means that you can jump, because if the clumps are too heavy, it means that this place is likely to be positive, and this place can even be likely positive. So you can estimate and jump about 2, then come and do the test here. Do the test here, you see that it is weakly reactive. If it's weakly reactive, it means that the next test will be what?
It will be negative.
It will be negative. So you don't even go and do this one for it to become negative. So you do that this one is weakly reactive. This one, if you dilute it, this next one is likely to give you a negative report. So your titer is here. If you don't use your mind on some of these things, one test can finish all your reagents. And you can't go and ask the patient that, oh, for your test, I did it 15 times before I got the final answer. So go and pay 15 times. The patient will pay and go. You will pay for the cost of the test and go. If you did it 15 times or 10 times or before, that one, the patient don't have to suffer. The patient don't have to pay for your wastage. So what you have to do is you have a fair idea about the intensity of your reactivity. You did here, and you saw that it's weak, just after the 2. This one is weakly reactive. I won't waste my time and go here, because you go here and the test becomes negative, you come back here and take it as your titer. So those things should guide you. Otherwise, I've said this, I'm going to repeat that. If you have a case which is very high, by the time you get here, you have done about 6 times, all your reagents will finish. So you have to be circumspect and also just be guided by the reactivity. If after this one, the clumps are too much, you can jump about 2 and then come here. Okay, if you come here, it is negative. It means that it's likely to be here. Okay, because this one was positive. Okay, and this one you jump to, and this one is negative. Then this is likely to be here. Then that's all. Otherwise, you finish all your reagents. Did you follow the discussion, please?
Yes, please.
Okay, thank you. And this one is saying that you mix 25 microliters of the patient's serum with this. Just this is all that you have said. And then at each point, you have to mix very well, because this must be mixed very well to be able to have a uniform solution. If you just put it in here and then just pick another one to come and put in here, your results will be wrong. So at each point, proper mixing after each dilution step is essential to ensure that the diluted solution has a uniform concentration. That's all. So this is a guide. All right. And this is a 10-fold dilution. A 10-fold dilution, here you're taking 9 mils. And here you're using broth. It is the same technique that we use in microbiology if you want to do colony count. Okay, all right. So here, the example is using broth. And this one, so your broth now becomes your diluent. So it is 9 mils across. And then this is your actual solution. So you put 1 mil into the 9. Once you put 1 mil into the 9, it is giving you a total volume of 10 mils. Out of the 10 mils, you have 1 in the 10. So this gives you 1 in 10. Then from here, because all these places have 9 mils, you are mixing here and taking another 1 mil from here and bringing here. This gives you another 1 in 10. Because this is 9 mils, you are bringing 1 mil from here to here. So this is giving you another 1 in 10. But this 1 in 10 is coming from this 1 in 10. So this 1 in 10 of 1 in 10. That gives you 1 in 100. Okay. Now you mix here. Remember, initially you have put in 9 mils in all of them. So you are mixing here and picking another 1 mil from here. If you pick 1 mil from here and bring it here, you have also created another 1 in 10. But this 1 in 10 is coming from a previous 1 in 100. So this becomes 1 in 1,000. Okay. And then so forth and so on. So this one, you're also doing tenfold. You see, because this one 100,000, sorry, 10, 100,000, 10,000, 100,000. So this is also in tenfolds. So, and this is serial dilution. So it becomes a tenfold serial dilution. A tenfold serial dilution. Okay, this is how you do it. Tenfold serial dilution. Okay, all right. Okay, it's the same thing that you are replicating here. A tenfold serial dilution reduces the concentration of a solution by a factor of 10. Okay, so this 1 in 10, 1 in 100, 1 in 1,000, 1 in 10,000, 1 in so forth and so on. Okay, all right. So after the first tube, each subsequent tube is the dilution of the previous dilution tube. Sorry. Each subsequent tube is the dilution of the previous dilution tube. I hope that point is clear. So total dilution factor of the second tube is equal to dilution of the first tube multiplied by the dilution of the second tube. This one too, I think you have gotten it already. So step by step, so now you've gotten the whole concept of the serial dilution. So step-by-step procedure in determining syphilis antibody. So like you know already, the process begins with a serum sample that has already tested positive. Okay, so that's where you are going to do dilution. Remember, and you rightly answered that even though your initial sample could be negative, if you're interested, you want to rule out prozone effect, you may still do a dilution and find out. Okay, because the first test could be even 1 in 2 could say, so the need sample could be negative. 1 in 2 could still be negative. Then you realize that 1 in 4 is rather positive. Okay, then it's still a demonstration of a prozone effect. So the original sample is positive. The sample is now serially diluted. You could do a doubling or 2-fold dilution or a 4-fold dilution. A 4-fold dilution means 1 in 4. So 1 in 4, the next one will go to 1 in 4 of a previous 1 in 4. That will give you 1 in 16. Then the next one will be 1 in 64. I hope now you'll be able to do the calculations for the serial dilutions. So yes, each dilution is then tested. Then each dilution is then tested using the same non-treponemer. So each dilution is now taken as though it is a sample, okay, and do the test, the RPR test for each of them. And then here you have the endpoint titer. You've already explained what is endpoint titer. It's the highest dilution of the serum that can still give you a positive or weakly reactive. And this one should guide you. Once it's weakly reactive, it means that the next one will give you a negative report. And therefore, you are always guided by where to get the weakly reactive result. Where you have a weakly reactive result, it means that the next one is going to be negative. Therefore, the point that gave you the weekly reactive result will be taken as your titer or your endpoint. So, for example, if a sample is reactive at y in 16, but not at y in 32, then the titer is reported as y in 16. Okay, all right. A titer of y in 8 means that antibodies can still be found as weakly reactive, okay, at y in 8. In this case, when one part of the serum sample is diluted with 7 parts of the diluent, which is the y in 8, then the test is still positive. But clumps can no longer be found at the dilution of y in 16. This is just still an explanation of the fact that where you have a weakly positive case, the next one will begin negative. And when that next one is negative, you come back and take the one which gave you the weakly reactive case as your endpoint. Some few interpretations. A titer of 1 in 1 means no dilution. So if you hear about 1 in 1, it means that it doesn't mean that add 1 to 1. Because as soon as you add 1 to another 1, we are going to get 1 in 2 dilution. So 1 in 1 means that there was nothing added. Okay, there was nothing added. So it means that there's no dilution. All right. Because you can have a situation where the sample was positive, but 1 in 2 was negative. You did just 1 in 2 dilution, it is negative. So it means that your titer is 1 in 1. You come back to the original sample. Okay, all right. All right. A twofold increase in titer is equivalent to 1 dilution. What it means is that, let's see here, a twofold increase in titer is equivalent to 1 dilution. Let's go back and then get this point clear. Okay. Now, from here to here, is it not? This is just 1 dilution, is that not it?
Yes, please.
Hello?
Yes,
this one is just 1 dilution. And this 1 dilution, you see that it's giving you a twofold. Because this 1 in 2 and 1 in 4, this is like a double, is that not it?
Yes, please. That's it.
So, yeah, so 1 dilution is equivalent to a twofold. So, in the case where we say that, once you have been treated and you are monitoring effectiveness of the treatment, you should get a 4-fold decrease. Do you remember that statement?
Yes, please.
That you should get a 4-fold. It's just 2 dilutions. So what? Because the 4-fold is from here to here. Because from here to here is like 4 times. Is that not it? From here, 1 in 2 to 1 in 8. You see that is what? It is 4-fold. It's 4 times. Is that not? It's 4-fold. However, from here to here is just 2 dilution, 1 and 2. This is all that we're talking about. So when you say 4-fold, it is just 2 dilutions. Just 2 dilutions. So if initial dilution was, let's say, 1 in 4, 4-fold will be just 1 and 2. And this will give you 1 in 16. So if originally the titer was 1 in 32, if you do a repeat, let's say some months later, a 4-fold is not like 4 times 1, 2, 3. No, a 4-fold is just 2 dilutions. So from here, 1 in 32, 1 and 2. From 1 in 32 to 1 in 8 is a 4-fold. That's what we're talking about. So 4-fold is not like 4 times dilution. No, just 2 dilutions. That will give you 4-fold, either increase or decrease, depending on where you are looking at it from. Okay. So this is all that I was trying to explain. All right. This we talked about the other time. Syphilis, the main session, the fact that syphilis can only affect your erectile function and not the size of your penis. I think we talked about this one the other time. Right. Time has gone past, and probably you can continue from here on Saturday. Next week, Saturday, we will try and finish. Even if you have to go beyond the 2 hours, we'll try and finish. And the rest are going to be very, very short. So you're going to look at other genital ulcer diseases. Remember, we said that you're looking at the penis and all that can affect it. And then we looked at the curvatures and blah, 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 the buried and so forth and so on. And then we looked at ulcers that can be found on the penis. And we started with the syphilis. Instead of just mentioning that syphilis will give you an ulcer on the penis and go on, I try to take the syphilis as a whole topic and also treat it for your understanding. And that has taken us to the aspect of titer determination and so forth and so on. In fact, this whole syphilis is a complete course on its own. And I'm sure that you have benefited from it in one way or the other. All right. So now we say that if you see an ulcer on the penis, most of the ulcers that affect the penis are due to sexually transmitted infections. Remember, we said that not all sexually transmitted infections affect the penis. That's why we didn't talk about HIV, we didn't talk about hepatitis B and so forth and so on. We are going to talk about sexually transmitted infections that will cause an ulcers on the penis. Okay, so it can also be considered as ulcerative STIs. And so syphilis can be said to be an ulcerative STIs. So if you're looking at the others, if you see an ulcer on the penis, it does not also say that it's syphilis, because there are other conditions or diseases that can also give you an ulcer on the penis. And these are chancroid, genital herpes, and lymphogranuloma venereum. So if you see an ulcer, these are all differential diagnoses. What it means is that if there's an ulcer on the penis, it could be syphilis, it could be chancroid, it could be genital herpes, it could be lymphogranuloma venereum. All right, this is the aspect of a scientist. Most of the doctors, once there's an ulcer on the penis, straight away all they know is that it is syphilis. And so, but you are a scientist, you do your syphilis test, everything, and rule out that it is not syphilis. If it's not syphilis, then what could it be? That's where your other things will come in. Oh, it could also be chancroid, because chancroid too is also can also manifest as ulcerative STI. For that matter, can give you ulcer. You also have the genital herpes, which of course is caused by a virus. Okay. Apart from that, you also have the lymphogranuloma venereum, which is also caused by bacterium, the chlamydia, certain species of the chlamydia. All right, so we're going to take a snapshot on all these things. When I take a snapshot, like we're going to go through quickly, and then we move on to other aspects. I wish that we could have finished all these things today, but of course, the time is you may be tired. I'm not tired though, but you may be tired. I don't want us to rush through just to finish it, but I want you to be able to understand what you're actually doing and then have an impact on your practice. All right. Sorry, today I think my network has been terribly bad. This was a good answer from Moses. I didn't see it earlier. Serial dilation can still be done when you suspect that there is proson phenomenon. Fantastic. Fantastic. And these are the things that I want from you. You'll be doing this chancroid, genital herpes, lymphogranuloma, and then continue with the other things. Then this one will be completed quickly, trust me. And then you will do some few things still on the penis. You will do penile skin conditions. Okay, that is also very short. And then you'll be done with the penis. You see that we've done a lot on the penis. And then you can do just little on the other aspects. Then it will be done. So by God's grace, if you're alive Saturday evening, please make yourself available. We'll finish with andrology. We'll finish with andrology. Thank you so much for your time, and God bless us all.
Thank you, Grandpa.
If there's any question, please, you're welcome. If there's any question you want to ask, please do. Today has not been too good with respect to network, and even myself, I'm still struggling to have this session. I have severe malaria with some flu. All right. So if there's no question, we call it a day. Good night.
Good night.